Today we're going to be doing problem 18.39, and this is going to be a question that asks you to understand Kc qualitatively. So they give us three species, which are NO3 minus, F minus, nitric acid, which is HNO3, and hydrofluoric acid. And they're asking us to find or make two equations where Kc is greater than 1 and another one where Kc is less than 1. So we'll start with the first part here. And so to do this, we have to realize that Kc, when it's greater than 1, that means most of the reactants are going to go forth and turn into the products. And the reason this is because Kc is the ratio of products over reactants at equilibrium. And this is a key point, equilibrium. So we can have equal amounts of this put into our solution, or we can start off with equal amounts of these two, but in the end we're going to end up with different amounts of our species as they react together. So to get Kc greater than 1, we want to have mostly products. Now to do that, we need to find two reactants that will react greatly with each other. So when we look at our species here, we see that we have an acid and an acid. And we should know from our studies with acid-base chemistry that HNO3 nitric acid is a very strong acid. This is one of the strong acids such as hydrochloric acid, sulfuric acid, nitric acid, and the hydronium ion. So these are all strong acids that we need to know about. So knowing that, we're going to make HNO3, try this out first, HNO3 as our strong acid, and we need to add it to another species that it'll react with. We're looking at this, we don't want to add it to another acid because it cannot protonate that acid. So we're going to add it to the hydronium ion. And so the nitric acid is going to protonate the fluoride ion, and we're going to end up with NO3 minus plus hydrofluoric acid. Now the reason why we didn't pick NO3 minus as one of the reactants is because once you protonate NO3 minus, you're just going to end up with HNO3 on the other side again. So this doesn't work. And when we look at this, we notice that this is an acid, and this is the conjugate base that we get out of it. So we found an equation where Kc is greater than 1. Now we're going to move on and find something where Kc is less than 1. So we used our species here. One thing that you should know is flipping the equation around will flip Kc upside down, so you'll end up with reactants over products. But when you write it out, you'll have NO3 minus plus hydrofluoric acid, and the hydrofluoric acid is going to protonate your NO3 minus, and you're going to end up with the fluoride ion plus HNO3. So before we had HNO3 and fluoride ion as the reactants, but now they're going to be the products. So we'll have concentration of HNO3 times the fluoride ion over NO3 minus and hydrofluoric acid. So this is our Kc for this equation. And this is going to be much smaller than 1 because, as you know, this is a strong acid. It's going to want to protonate the fluoride ion. So you're not going to have very much of this species in here. It's going to be very, very small. So you can have something very small over something that's much larger. So you're going to have Kc less than 1. So the thing you need to learn from this is what Kc means and how to figure out what kind of species you have up here. What's a strong acid and what could be used as a base.